All right, today we're going to do some double derivatives. Some double derivatives. It's going to be excellent. Double or nothing is what I say. Why not? Okay, so double derivative just means we do the derivative twice. Okay, so we do a derivative once, so let's take a function, fx equals x squared sine of 3x. And all right, we're going to do a derivative twice. We have to do it once to start with. So let's take it once. So what do we got here? We've got a function multiplied by another function. So I'm going to use product rule. Product rule is a piece of cake. We'll just take the derivative of the first function, 2x, and times it by the original second function. And then add on the derivative of the second function. So that's going to be 3 cosine of 3x. And I'm going to multiply that by x squared. Okay, there's my first derivative. And that's all well and good. But now I need the second derivative. So if this is the notation for the first derivative, you can imagine that the second derivative, 2 dashes, it's good, double prime, f double prime x. It's very exciting. But in both of these cases, we're going to have to do a product rule on this one, then a product rule on this one. It's going to get very long, so I'm going to write a little smaller and hopefully fit it in one line. Okay, so take the derivative of the first function times by the second function. So that's just 2 sine of 3x. Hopefully you can read that. And then the derivative of this function, which is just, what have we got? 3 cos of 3x times 2x. So all up I've got 6x, because 3 times 2. Cos of 3x, hopefully that's right. So that's the derivative of that bit, right, using product rule. Now I've got to take the derivative of this bit. Let's try that. Hopefully that's still recording. Yep, seems to be still recording. All right, so let's do this one. Okay, so I should have written this out a bit nicer. So this is 3x squared. So let's take the derivative of 3x squared. Gives me 6x. So that's the derivative of 3x squared times cos of 3x. Very nice. And then I'm going to add on the derivative of cos 3x. So that's going to be, well, I've got 9 because I've got a 3 out the front. So I've got, well, it's not going to be plus, is it? It's going to be minus 9x squared sine of 3x. Hopefully that's right. That looks okay to me, I think. Okay. Hopefully you've done that all in one step. So let's just double check. So 3x squared, the derivative of that, times cos x, so it's just going to be 6x. That seems fine. The derivative of cos x is minus sine. I'm going to multiply it by 3 because of that in there. Gives me the 9. Multiply by x squared. I think that's right. Okay, that's it. Okay, well, we could simplify that a little bit if we wanted to. Let's do it in blue because these are like terms. So I only need one of them. So I've got 2 sine of 3x plus 12x, 12 altogether, of cos 3x's, minus 9x squared sine of 3x. And depending what you had to do with it, you could take out some common factors. We've got a common factor of sine in a couple of these terms. We could take them out, but let's not add extra complication where there doesn't need to be. Okay. All right, so that's the first bit. What else are we going to do? So that's double derivative, right? You just take the derivative twice, too easy. Okay, but what happens when you have implicit double derivatives? So you're going to have to, when you're taking when you do an implicit differentiation, can you still take a double derivative? Hopefully we can. Let's just take a really easy one. Let's go x squared plus y squared equals 9. Okay, let's see what we get here. Look, we're not going to get dy squared dx squared, but let's just show you what we get. What we get here, we get an equation that involves double derivative. Okay, so for implicit differentiation, to take a derivative, we take the derivative of each of these bits with respect to x. Okay, so x squared with respect to x, we've done this before, we get 2x. So that's easy. To take dy squared with respect to x. Okay, so I just take it with respect to y first, and then times it by dy dx. Okay, and then 9's a constant with respect to x, it's just 0. So I could rewrite that as just dividing both sides by 2 equals 0. Okay, so there's that. Now, what happens when we do implicit differentiation again? Let's do it again. Okay, so what do we get here? We're going to derive this one with respect to x. Maybe I'll write it up here. X plus y dy dx equals 0. Okay, what happens? Take this one with respect to x. I get 1. Now, this one with respect to x, this is looking a bit tricky. We might have to use a bit of product rule here. So let's take the derivative of the first one and times it by the second one. Now to take the derivative of this first one with respect to x, well, that's going to be, take it with respect to y first, 1y, but then you've got to take it with respect to x, so times by dy dx. So that's the derivative of that bit. And then I multiply by this dy dx. So now I've got dy dx times dy dx, right? Plus the derivative of this bit, which is the other notation for our double derivative, d squared y, means this is the double derivative. This is the same as f double dash, yeah, or f double prime of x, and then times that by our original function y, and the double derivative of the derivative of 0 is still just 0. Okay, so what have we got now? Let's tidy up a little bit. 1 plus 1 times dy dx times dy dx. Well, that's dy dx squared, all squared. Okay, so this is taking this is the first derivative, and I've squared that function, plus y times the double derivative. Okay, equals 0. Then we end up with what's kind of like it's a differential equation. It's an equation that has derivatives in it. Okay, equation that has derivatives. Okay, so this is a double derivative, this is a single derivative, but the whole thing is squared. We'll talk about differential equations further on, but this is a first glimpse of what that might look like. Okay, and that's all we can really do with that. I think we'll just leave that there. Won't do any more with that. Let's do one more example. One more example. Instead of implicit, we'll do parametric. Parametric double derivatives. Oh, this is the most exciting video we've done so far, I'm sure. Okay, let's do some parametric equations. We've got x in terms of t. We've got x cos t and y 3 sine of t. Okay, let's start there. Alright, so we need to take the first derivative first. Now we did that. We've done that before. We'll take these derivatives with respect to t first. So we'll get dx dt. What's that equal? That's going to be negative 2 sine of t. Easy one. dy dt. What's that? That's 3 cos of t. Very nice. Excellent. But we want dy dx, yeah? This is what we're aiming for. So to get dy dx, we already know how to do this. We've got dy dt. What do we have to multiply dy dt to get dy dx? So we want to get rid of the t, so dy dt, or dt is going to be on top. And then times by dx to get dx on the bottom. The dt's will cancel out and we'll end up with dy dx. So this is dy dt, which is this one. 3 cos of that multiplied by the reciprocal of this one. So I've got negative 1 on 2 sine of t. So that's negative 3 on 2 times cos of t on sine of t, which you could also write as cot of t, couldn't you? So negative 3 and 2 cot of t. Okay, I'm running out of a little bit of room, so I might try and remember that and rub it out before we do the second derivative. So this is dy dx. So we'll rewrite that up at the top. So we've already found dy dx equals negative 3 on 2. Let's write it as one fraction. Oh no, that's a bad idea. It doesn't matter. Okay, what have we got? Cos of t, sine of t. Okay, there we go. That'll do. Okay, so we want to take a double derivative. We want d squared y on dx. This is dx squared, sorry. And we've got this function. So we're going to have to use a bit of quotient rule here. Unless we know what the derivative of cot is, you might already know that, but let's pretend we don't. If you're in an exam and you happen to know it, well, you can just go straight to the answer. But for example, let's pretend we don't know what the derivative of cot is, and we'll do it by quotient rule. Okay, so we're going to get negative 3 on 2. Let's leave the constant up front. Okay, we square the bottom one. Sine squared t, and we put the bottom one straight up, so just the original bottom one, sine t, times it by the derivative of the top function, so that's negative sine of t. Looks like we don't run out of room here, minus, what's next? Well, we've just done the derivative of the top one, so we want the top one, cos of t, times the derivative of the bottom, hang on. Yeah, that's right. Times the derivative of the bottom one, so cos of t. Forgetting this 3 halves out the front. I just left that out the front. Okay. And there we go. All right, beautiful. So this should be our derivative. Negative 3 halves of times negative. Let's bring the whole negative out the front of this fraction. Negative. Because we've got sine squared t plus cos squared t, right, because I take the negative out of both, put it out the front. These two negatives cancel. Let's make them both pluses over sine squared of t. Hopefully I haven't made a mistake. Sine squared plus cos squared is 1, so I just end up with 3 halves of 1 on, oh no, I think I've mixed something up. Hopefully I haven't. Okay, let's keep going with it. Okay, sine squared of t. Oh, I've just got this feeling. Hopefully, maybe you can see it. So this is sine squared t. Got a bad feeling about this. What have I done wrong? Okay, it looks very nice. So 3/2 of cosec squared of t. That's not what I got last time I did this. Ah, what am I doing? Dy dx. Oh no, that's right. No. Oh dear. Oh, of course. Of course. This is why I'm getting it wrong. Oh, jeez. This is dy dx. I've taken a derivative with respect to t, right? This is not right. I want the derivative with respect to x. All right. This is... you knew. Okay, so I need to multiply this. If I've done with respect to t, then I need to multiply the answer by, I want to get rid of the t's, dt dx, to get it in terms of dx. Now we're right, we'll follow this back through, dt dx. Okay, this is what happens when you only take one take in a video. Make mistakes, do silly things. Okay, dt dx. All right, so we know what dt dx is. We've already taken dx dt, right? Was negative 2 sine of t. So I need to multiply this by negative 1 on 2 sine of t. Now we're getting somewhere. So what will I end up with here? I end up with another 2 times here, so this is going to be 4. And we've got sine, so we get sine cubed, so this becomes a cube. There we go. Now it's with respect to x, because we can use the chain rule, right? When we take the derivative with respect to t here, instead of with respect to x, we need to multiply by dt dx. And there we got it. Okay, that's enough for one video. Hopefully that's correct now. I'm sure you'll tell me if I'm wrong.